introduce them in a minute. So first of all, if you called in, you don't need to call in if you have speakers and a headset. You can just listen on your headset or the speakers of your computer. If you can't hear, click on the speaker icon at the top left of your screen. So if it's white, click on it and it'll turn green like this at the bottom, and that's how you get to hear. If you're having problems, just type something in the chat and someone will try to help you. So I'm assuming you all know how to type in the chat. If you could just type in the chat and say hi and where you're from, that would be great. We'd love to know what institution or agency or school you're from and what you teach or what your role is. Also, if you're sharing a computer with somebody else, we'd like to know that so we can have an accurate attendance record. This webinar is going to be recorded, so we're going to start recording. Oh, I guess we already started recording. So we are recording. Here are your 4 presenters for today, and I'm very excited to have every single one of them. Rhonda Balmain is the principal at Folsom Cordova Adult School, and Brett Sanchez is a math professor at American River College, and they have collaborated with each other and and more people in the math work group of the Capital Area Regional Consortium, aligning curriculum for adult education to community colleges. So they're going to both be talking about that project that they worked on together. Tricia Willett from Mount Diablo Adult Education is going to talk a little bit about the work that they've done there, quite a bit of different things to support development of math skills in adult education students and transferring them to the colleges. And Mala Allen is at College of Marin. She's also done a lot of work with her consortium in Marin on transferring adult education students, and they have a program there that she'll be telling you about. So we have a lot to do today. I'm going to be quiet in just 1 second, and we'll begin with Rhonda Balmain. So Rhonda, go ahead.
Well, hello there, everybody. Thank you so much for participating in our webinar. We are going to be presenting to you our Math Success Academy, and Brett and I will be sharing in this presentation, and I'm going to just talk a little bit about the background of it, and then Brett will talk more about the logistics of the course. So if I can go on to the next slide. So these are the objectives of what we would like to talk about, or what I will be talking about. A little bit about statistics as far as math and how it relates to the adult student. Our background of who our students are, what the priority is of our regional consortium, how we are changing the structure of our adult education classes, and then we're going to share a little bit about the logistics of the math class, and then the pilot. So I'm sure that everybody's aware of a lot of the statistics surrounding math. So I got this according to data provided by our school district, Folsom Cordova Unified School District, and dataquest.org. Every year in the United States, nearly 60% of first-year college students discover that despite being fully eligible to attend college, they're not ready for post-secondary studies in math and end up in remedial classes that they have to take for no credit. Those classes cost money, and they're not transferable, or they're not counting towards their goals of education or of graduation in the college system. Slide. So how this all came about was we enroll students into our adult ed program every single week, and we CASAS test them in the orientation process. And so the scores from the CASAS math test reveal that most of our students score well below grade level, many as low as the 4th grade in basic math skills, or even lower. And they're coming into our programs to enroll, obviously, into our high school diploma program or our high school equivalency program to earn credits to graduate or to pass the now rigorous exam to get the high school equivalency certificate. And so because their math skill level is so low, the students spend way more time in our programs just trying to get through the math than they want to, than their expectations are for our programs. So they come into our program and they're expecting to pass these high school level courses, these math courses, really quickly. They want to come in, they want to get it done, they want to turn around and get out and move on to their next thing, whether it's to go to college or get a job or go to a vocational training program or whatever it is that they want to do. But math is like a brick wall. It's a barrier. They can't get past it. So as a result of that, many of them have very unrealistic expectations. They struggle, they get frustrated, and they lose motivation. Slide. I just lost my slide. There we go. So the students usually don't pass the math courses that are required for graduation because, again, they don't know the basics. They have significant gaps in their learning, or it's been years since they've done math and they can't remember the basics. And then also a lot of students come to class with the barrier of, I'm not good at math, or I don't have a math brain. I hate math. I've never been good at math. I've always failed math classes. It's like a disability. It's debilitating to them to know that they have to struggle through it. Slide, please. Not seeing my slide. Can we go on? Right. Okay, thank you. So when our students come into our adult ed programs, most of them are coming into some sort of an independent study format where they're working independently on the coursework to earn the credits. And that makes it even more difficult for them to learn the math because they're trying to learn it, again, independently. So a few years ago, I did some research on what our local community college was doing as far as helping low-skilled math students coming into college first year and ending up in the remedial courses. And so long story short, I learned about the Los Rios Community College District up here in our Sacramento area was doing a remediation boot camp over the summer. And it was a 6-week, fast-paced, intensive, focused, basic math remediation that prepared students for intermediate algebra. The students would enroll into this class for 5 days a week, 3 hours a day, sometimes 4 hours a day, and were able to get what they needed in a 6-week period of time. So that I had that knowledge in my head. This was about 6 years ago, and so I always remembered this. And I went and I met with the dean of the math department over there. I observed the classes. I looked at the curriculum. I talked to the students. I did a lot of background checking on this particular mode of teaching. And then fast forward to recent, the work of our consortium here in the Sacramento region, we're the Capital Adult Educational Regional Consortium. We met as a group, and this subject came up again about the math and about the English and the concern that we had for our students entering community college without any of the basic skills. So our consortium made it a priority that adult schools and our local community college would work together as a team to create a course to remediate students with very, very low skilled level math. And we needed something that was fast-paced. We needed to build the student confidence, And we needed something that was going to fill those holes. Next slide, please. So that being said, and I'm sure what I'm saying is not news. I think everybody that works with our adult students knows that this is a big struggle. But what do you hear your students say about math? Or how do you teach math at your particular school? Is it one-on-one independent study, or do you have whole group instruction? And if you could change one thing about how your students learn math, what would it be? So I'm just curious to get, to take a minute or two to get your thoughts on that. If you can just type in your response, that would be great.
Rhonda, while they're typing, Lilia is asking if your students are Hispanic students or English speakers I guess.
Oh, I just saw that. Yes, thank you. They are English speakers. Actually, they're both. They're both, but mostly native English speakers. So I see computer-based, independent study, direct instruction. What do you hear your students say about math? Every problem is different. It is difficult to see the pattern. Absolutely. Oops, wrong window. How is math taught at your school? Face-to-face, and then given worksheets during the lab to practice. That's great. Direct instruction, that's fantastic. And then, of course, there's some really good computer-based programs out there. I know that we've used Alex Math. Changing how your students, what's one thing you would change how your students learn math? I'd like students to not be afraid of learning math. Yeah, definitely. Make it fun and to persist through the problems. These are fantastic responses. And we are all experiencing these same things. Some classes are computer-based and others are lecture format. Excellent. So everybody's experiencing the same types of struggles with math remediation. Okay. All right. So thank you, everybody. Let's go on to the next slide if we can. I want to be very conscious of my time. I don't want to go over. So our particular Math Success Academy, and if we can go on to the next slide, I'd appreciate that.
Are you saying logistics of the class, Rhonda, or do you want the one before that?
The one before that.
Yeah. Okay, we see it.
I don't see it on mine. Okay, interesting. Okay.
Well, tell us about
there. It is. Got it. Okay. Sorry, I got it now. So this class was designed very, what do you call it? We were very focused on how we wanted this class to be designed, because not only did we design it with the lesson plans in mind. Okay, this is a 40-hour, fast-paced boot camp that meets, I'm going to show you our calendar. It meets for 5 weeks, every single day. Well, it's Monday through Thursday. It's 2 hours a day. It's closed enrollment. And there are several things that are going on in this particular class, one being the curriculum, obviously the math lessons, but we also changing the structure of how we teach the math and what the classroom looks like. We're trying to help our students think differently about math. We are building their confidence. That is a huge part of this particular course. We teach with the Common Core critical thinking for our students to solve the problems themselves. There is a ton of flexibility in the class. It is a student-centered approach. We focus on developing a growth mindset. We use a lot of different learning styles and methods. And then our team, our consortium team, the group of us that developed this course, I mean, we support the novice math instructors who are teaching this class to help them with the strategies that they need to make it successful. And we also work with the experienced math teachers to kind of extend the way they're teaching the math. But the bottom line is it has to be fast-paced. Students have to see immediate growth, and they have to start changing the way they feel about math. So that being said, like I said, this is a copy of our calendar on the next slide. The class is Monday through Thursday, 2 hours, 5 weeks, 40 hours, and we pass out this calendar, and the students know exactly when the class is going to go. They're committed to it. As soon as they enroll into our programs, that's the first thing we do is we enroll them into the Math Academy. No matter how many credits they need or what they want to do first or whatever their path is, if they need math, this is the first place they go. Okay, next slide, please. Okay, and so after we piloted this class in the spring, part of the components of this class is a pre and a post assessment. It's a numeracy assessment that has, I think it's somewhere around 40 math problems. Every single math problem, I'm sorry, 29 math problems, my bad, 29 math problems, but every single math problem mimics obviously what they're going to be learning in the class. And you can see these pilot results. I have 7 students, and there's a pre-assessment score and a post-assessment score. So out of 29 problems, the first student only got 1 right on the pre-assessment, but 17 right on the post. Then the second student got 15 right on the pre, and then 25 on the post. So if you look down the list, every single student made a gain, and some a very significant gain. But the most incredible part of the pilot, what we found, was they changed their mindset because, as you're going to hear from Brett, math mindset, growth mindset, is a big, big component of what is happening in this classroom. Okay, so next slide. So there are, I added, the last couple of slides that I have here are just, I wanted to show you a couple of the resources that will make sense after you see more of the curriculum from Brett. But we use very specific resources such as the composition notebook and a toolkit. So the composition notebook, every student has one, and if you look at the picture of a sample of what the notebook looks like, it's really important that the students keep very clean, organized notes that are synthesized, that are sequenced, and that the student can reference. They can flip through their pages and boom, go right to a page or a problem that they're looking for, and the teacher can find it as well. Have you ever looked at your students' math work and there's just problems all over the page and it's a big mess? So we teach organization, structure, sequence, really important to their learning. And then the toolkit is a wonderful tool where you take a piece of paper, just a regular size, 8x10 paper, and you fold it into squares, and each square a student at the end of the day reflects on the content that they learned that day. So if they're learning something like two-step equations, they will write in one square, today I learned two-step equations, and this is how you do it. And they write it in their own hand, either as a sample problem or in words. They can use sentences, whatever it's going to take for them to reflect on what it is that they learned. And it's kind of like something that they can also reference back, and it's an at a glance. It's a really great resource. And then last, the books that we are definitely recommending. The first one by Joe Bowler, The Mathematical Mindset. A lot of the curriculum and the teacher notes that are in our curriculum come from these resources. So anyway, that's my portion of the presentation.
Thank you so much, Rhonda. First of all, your timing was perfect. Absolutely. I love that, having a reflection about what you learned and how you learned it after every class. I think that's a great practice for not just math, but everything. So we're going to switch over now, Winnie, to Brett Sanchez from American River College, and he was a key contributor to the curriculum for that math class that Rhonda just told us about. So I'm turning it over to Brett.
All right, thank you, Marian. Thank you, everybody, for coming here. I'm interested to share with you what we're up to in the capital area here. we are going to talk about how we're leveraging the growth mindset in our curriculum to, as the title says there, enhance student success. So in all of this, there's sort of this theme of pathways and developmental sequences that we're clarifying. Right now, as educators at many levels, we're correctly spending a lot of time to clarify the effective sequences for remediation, find the most effective pathways for students to get from where they're at, needing a significant level of remediation and developmental mathematics, to where they need to be, whatever their goals are. At the community college level, this is recently something of a mandate. The language that has shown up in recent legislation is indicating that we need to clarify these pathways very well for our students and make the transition from lower level mathematics to college level mathematics pretty smooth. And at Adult Ed, this is one of the primary tasks with the consortia. Right? This is one of our goals in what we're doing with these consortia, trying to clarify these pathways. But the reality is that the pathways and the sequences that create are going to depend a lot on what curriculum we're using. If we have great pathways and great sequences, but our curriculum is junk, then they're still going to fall flat on their face. The success rates will still be low, and our students won't be learning what they need to. So it's really important that match with clear pathways and successful sequences of developmental classes that we have quality curriculum. So I want to stop for just a second, and I don't want to take too long to do this. We're going to get behind on time, but I do want to hear for just a second what challenges, when you look at the curriculum that your schools are using, what challenges does your curriculum present? Or what barriers does your curriculum put up maybe? And maybe it's not putting up any at all. Maybe you have a wonderful curriculum, but I know when we look at ours at American River College or just about any institution, there are things that we find that we can improve. Okay, so we've got a lack of instructors. I've heard that a lot in the Sacramento area. We have a distinct need for more instructors. So you're not alone in that, Sarah. Okay, different starting points in independent study, assume proficiency in earlier areas. Yeah, so we have lots of sort of different starting points, and different people have different gaps and holes in their understanding and where they're starting at. It's not just a straight linear progression. Too much going on all at once. Identifying specific skills that we can work on might be helpful to that. Contextualized to CTE courses. Yeah, a lot of our work in math is sort of decontextualized, and there's a very real value to that. That's a primary standard in the Common Core standards, but at the same time, if we have people with CTE goals, that would absolutely be something that would be valuable to be able to contextualize that. Great, thanks for your input there. So when we looked at our curriculum in the area, we talked to teachers, we talked to administrators, and we saw some challenges. We saw in the math curriculum itself a pretty heavy emphasis on memorizing methods. We're looking at a goal of getting through a problem rather than understanding what's going on. So it's just memorize a process that we would apply here without any real understanding of what's going on. We saw a lot of shortcuts being taken in terms of, hey, here's a trick to get, again, to the end of the problem without understanding why it works, without understanding the deep meaning of this problem. We just know if we see this, we can do this little trick and get us to the end of the problem, and that way I can just get a right answer. All of this sort of leads to a sort of short-sighted approach. We have students whose immediate goals are, well, to begin with, maybe immediately passing a class or getting credit. Ultimately, some of them might be looking to pass a test, high school equivalency test or something to that effect. But the question that we wanted to ask was, once they accomplish that, what's next? So if they need to go to college or they need to go into CTE direction, are they actually prepared for that? Did they just pass a math class and check off that box, or did it give them any preparation for that? So that was important that we look at that, and we found a lot of our curriculum wasn't preparing them for those next steps. And finally, the curriculum simply oftentimes isn't intellectually stimulating. More or less, it comes down to do this math problem because math class says so. And we're not talking about necessarily real-world application problems, but there should be some kind of questioning, some kind of, what happens if, or what went wrong, that kind of intellectually stimulating type of discussion. And most of our curriculum wasn't supporting that. It was supporting a sort of, here's a method, here's some things that you need to memorize, and go with it. So we created our own curriculum from the ground up. And I'm not going to be here to claim that it's the most amazing thing that's ever been created, but we at least set out to accomplish our specific goals and customize it for what we wanted to do with it. So we made something that was totally different, except that it wasn't really that different. We just wanted to do something pretty simple well. So what we don't have is anything that's revolutionary here. We're not teaching some new mathematics. We're not turning education on its head. We're not doing anything that's going to massively change the world. We're hoping to move the needle a little bit and make a smaller difference in the very specific areas of mathematics in some of these students' lives. So it's just based on good practices. We're trying to use good practices and use them consistently and use them well. So for instance, we'll see less direct instruction and less lecture, more exploration, more doing, more hands-on exploring. I mean, already we're 20 minutes into this presentation, maybe 25. You're probably tired of hearing our voices talk, right? In general, it's a lot more engaging if you can go do something. So our students are even that much more sort of ready to get to work doing something. And so when we provide that opportunity, it's going to be a better place to learn. We have a strong emphasis on connections and relationships. This is as opposed to that sort of short-sighted view. We're taking a long view. If we have students in an arithmetic class, the things that they're learning in arithmetic are important for arithmetic, and they'll use those in very real applications. But if they plan to go on to take algebra, those things that they're using in arithmetic will come back. And if they understand those things in arithmetic, then it will be a lot easier to understand them in algebra. So we're looking at developing deeper connections rather than just doing the task at hand. And then finally, the thing that you all came to see, we really try to emphasize what's known as the growth mindset. So if you're not too familiar with the growth mindset, it's kind of a buzzword right now in education, and it's unfortunate that sometimes it just gets labeled as a trend because it's a really valuable way of understanding how we learn. It's a set of concepts that have really been made popular by Carol Dweck and her research, and further popularized by Jo Boaler. A lot of her writing has included work with the growth mindset. These are heavily research-based writings and opinions that they're presenting. But they emphasize that success largely depends on, or at least significantly depends on, our own approach to learning, whether or not we actually view ourselves as being able to learn. So it's a really important thing to understand this growth mindset. So at this point, I want to take a quick poll. How many of you feel like you're good at math? So it's just a quick checkbox, so there's no reason that I shouldn't see as many answers as there are attendees. We got 10 there. All right. Maybe a couple more. Give it a second. All right. We got 10 people who are doing this. All right. So no surprise there. Many of you consider yourself above average. If you are involved in teaching mathematics, that probably should be the case. Some of you consider yourself average or below average. And so there's nothing morally right or wrong about any one of those spots. I just wanted to kind of see where people landed at. So then the next question is, really briefly, and this is something that can't truly be answered briefly, but in one sentence or so, what are your thoughts on how does one become good at math? So what does it take to become good at math? Use. Use is a great one. If we're not using it and practicing it, then we'll probably lose it. Persistence, yep, got to push through. Confidence, understanding concepts in many different application areas. That's a useful one. That being able to apply the ideas in different areas can be very helpful at understanding mathematics. Practice, 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 yes. Relevant information, applying concepts to lots of application. So one of the things that we do see here a lot, we see practice, like lots of effort, lots of doing, right? It's an active thing. And we see confidence and persistence. Those are a couple of things along with applications there. So I want to keep those in the back of our mind. I agree with all of those ideas. So as we look at the growth mindset, really it's kind of a meta idea. It's understanding how we learn. So we're not just learning math. We can look at how we learn math and learn about that. So to learn effectively, our students can benefit by understanding that process. So what do we want our students to know about that process? Well, the first is that math is a learned skill. It can be gained and acquired. It's not something that is just there. It's something that we can pick up. And that means it can be improved. This is really important for our students. This is so incredibly important. By definition, our students who are in adult education, or in my case in our developmental sequences, are somewhat behind in mathematics compared to where we judge they should be. So they get the stigma of being bad at mathematics. And it's important for them to understand that if math is hard for them, there's good news, they can get better, right? They can improve. And the brain is kind of like a muscle. Working it out, hard work, doing the right things makes it stronger, so we can get better at that. Another really key thing that piggybacks off of that is that math is not an innate skill. We're not born with it, we learn it. So that doesn't mean that some people aren't wired in ways that make it easier or harder for them, but the skill itself is still learned. So for instance, I'm a mathematician, but I'm a mathematician by training. I'm a mathematician because I went to school for a lot of years to learn how to be a mathematician. I wasn't born a mathematician. I hear things all the time from people that say, you probably did really well in math in high school and stuff like that. And the truth is, I was an average good student. I never went further than Algebra 2 in high school. I wasn't some math superstar. I just did a lot of math later on and learned how to do it because I spent time doing it. It's something that you can gain, and our students are no different from that. So in order to be successful, we do need to employ a couple of different approaches. First is that we need to have good strategies in learning. So we do need to practice. We do need to work. But if we're not practicing the right things, if we're not working in the right directions, it's not going to be useful, right? If we need to walk somewhere, walking in the wrong direction is not going to get us there. Yes, we'll need to walk, but we need to walk in the right direction. And these good strategies are kind of like the compass that guides us in the right direction. But along with that, we do have to do the work. So nothing in learning happens sort of by accident or passively. We have to actively do the work. So we need our students to understand that it's going to require consistent and constant effort. And finally, oops, I skipped ahead there. Finally, persistence. And that showed up a couple of times in the ideas about how we get better. Persistence is huge. Probably one of the most, probably the most important of these three, assuming that there's some notion of effort. Our students get hung up on persistence. They assume that if it's hard, that there's something wrong, that they're intrinsically doing something wrong inside their mind if they're finding difficulty. And so this is the key. When it gets hard, we've got to keep going. We have to be persistent. So these are things that we are working on our students explicitly understanding. So Math Success Academy is built on that growth mindset. And it shows up explicitly. We want to talk explicitly with our students about these things, and it shows up implicitly in the lesson plans. So we're going to look for the last part at how that shows up. So on your screen here, you see a shot of the first lesson. This is day one that they come in. And we're really, on day one in class, you're setting classroom norms. You're setting the standard for how we want the class to go, what we want people to think about the class. And so I want to draw attention to a couple of things here. In the very first line here, says, at the end of the lesson, students should understand that learning is a process and that each of us can actually get better at math given the right approach to learning. Right, that really summarizes the notion of the growth mindset, and we really want to hammer that home to our students. That's what we want them to understand. Each of us can get better. It's about movement in the right direction. If we go down a little bit, halfway down the page where it says ask students. So it says ask students for an example of a skill that they might decide to learn, or in this case, that they might already know. Everybody has something that they're good at. It doesn't matter what it is. Everybody has something that they're good at. So students, if you ask them what they're good at, they can always find something. And when you ask them how they got good at it and they stop and think about it, they'll have no problem telling you that they got good at it because they practiced it, because they focused on getting better at it, because they watched YouTube videos on how to improve at it, because they spent their spare time doing it. These are things that our students know and understand. Unfortunately, oftentimes they don't bring that over into mathematics, so this allows us to tie in the idea of things that they're familiar with to the math classroom. So they already understand the ideas of growth mindset. Now we need to apply it to mathematics. One other thing that I want to highlight under the direct instruction part, it says at this point the instructor should share a brief personal anecdote describing an example of a time when he or she experienced struggle and overcame with hard work, strategies, and help from others. This is really important because it highlights that growth mindset is not just for those who are sort of failing or the weak or those who are behind. Growth mindset is the strategy that successful people use. So we're looking at an instructor who the student probably sees as a successful individual, and the instructor is saying, yeah, this is the approach that I use to be successful as well. It's not just for people who are bad or having a hard time. This is how we need to approach things in order to be successful. There are a couple of misconceptions about growth mindset that I do want to highlight real quick just in case anybody's concerned. There are a couple things that it's distinctly not. It's not meaningless encouragement, which oftentimes shows up in phrases like, or sentences like, all effort is productive and should be affirmed. Just because somebody's working doesn't mean that they're working in the right direction. It's good that somebody's willing to put in effort, but again, those strategies are important, so we need to make sure that people are going in the right direction. It's not ignorant of progress. So that's to say, we're not interested in kind of saying it doesn't matter that you don't understand, at least you tried. No, again, we want to be moving the needle. We want to be gaining understanding. And if they're not gaining understanding, then we haven't really, truly made it anywhere. So it's important that we not lose sight of that. And then finally, it's not relativistic. So all answers are equally good. Oh, you tried, you got an answer. Good, that's a perfectly good answer. No, a right answer is a right answer, and a wrong answer is a wrong answer. The difference here is that we don't want wrong answers to be stigmatized. So we don't have to call it right, but we also don't want them to be stigmatized. Wrong answers can be very valuable. Mistakes can be important. We're going to talk about that in just a second. So on the implicit side, it does show up in the lessons, sort of in the background. It really shows up kind of everywhere in the lessons. So let's look at kind of how we see that. In the warm-up questions, the warm-up questions are encouraged to design, or are designed to encourage exploration. The idea here is that the journey is really more important than the destination. So yes, progress, right answers are good, but the way that we develop accuracy and getting right answers is through refining the journey. So let's look at an example lesson here. Here we're talking about rates. And we might have a problem here. If we look at the warm-up and introduction, we have a fairly stock kind of problem about rates. With a question, who's working faster and who's working slower?
Brett, I'm just going to...
Yeah? Perfect.
You have about 1 minute.
Perfect.
1 more minute.
And the idea here is we want students to explore, to play around with this. It's not about getting the proper math notation and stuff like that. It's about understanding the problem and trying to refine ways of thinking about the problem. So that's the biggest idea. Again, mistakes are okay. We want to learn from them. The instructor is not there to hold hands and to give the right answer. They're there to facilitate learning, help the students to learn. And finally, the last thing is exercises are designed to illuminate the ideas. So if we look at the exercise sheet for this lesson, Problems 1 and 2, again, are pretty stock scaffolded problems. Problem 3 requires some synthesizing. So problem 3 now, we're comparing rates. They have this overall question, and now we have to take the concepts that we've worked on, where we haven't explicitly done an example like this, and try and find some way to contextualize that and use these ideas and synthesize these ideas into some connecting concepts that helps the students to place what the meaning of this is. So that really covers everything that I wanted to talk about. I don't think we really have time for any questions, but thank you for attending and paying attention for this.
Thank you so much, Brett. And go ahead and type your questions into the chat if you have questions, and we will try to get back to them at the end, but I don't want to shortchange our other two presenters. I know we're packing a lot into an hour here, but we're going to go to Tricia Willette from Mount Diablo Adult Education in Concord to share what their program is doing with supporting students in their math skills. So, Tricia.
Thank you, Marion. Can everybody hear me okay?
You sound good.
So as Marion, everything's okay? Okay. So as Marion said, my name is Tricia Willette, and I am the program coordinator for the High School Diploma, High School Equivalency, and ABE program at Mount Diablo Adult Education in Concord. And I forget I can do the slides now here. And so I wanted to tell you today about a workplace math course outline that was written not by me, but by our work group, our ABE work group in the Contra Costa County Consortium. This consortium work group consists of instructors from 8 adult schools: Pittsburgh Adult School, Martinez, Antioch, Liberty, Acalanes, the county, Contra Costa County Jail System, West Contra Costa County Adult School, and of course Mount Diablo Adult School. And then 3 community colleges: Diablo Valley College, Los Medanos Community College, and West Contra Costa Community College. So these were all instructors. We've been working together for a couple of years. We're starting on year 3. The first year we had a lot of people, stopping and starting in different phases. I don't know that we got a lot done that year. But last year we really gelled, and we started working on the math. And our original intention was to try to get a course or figure out how to get students to be college ready. And as we were all, and when I say that, I mean the transferable level. And so as we were all talking, we kind of realized that the adult schools had teachers that could teach the higher level math classes, but we just didn't have the students that were ready for the higher level math classes. And then as we discussed a little bit more, and we had, the year had started and we were surveying students, we found out that a large majority of our students are really more interested in the career tech programs, and that was actually a big population for our adult schools. So we went to work on this workplace math course outline, and I think that it is attached. I can't see part of my screen, so if it isn't, we are happy to share that with anybody that's interested, and you're welcome to email me, and I can send it to you, and I'll send it to you in the Word document so you can change it or use it or change it however you like. But this workplace math course outline is contextualized to construction, healthcare, and the business information worker career pathways. We are piloting it right now here at Mount Diablo Adult Education. So since we're piloting, I don't have any data to share with you, but I can tell you that it is a class that meets 2 days a week, Mondays and Wednesdays, 2 hours in each class, and I have 2 of those classes running right now, and both of them filled up at registration. And we had a little bit of a hiccup with our teacher who was going to teach it, and so the first couple of days I had to teach the course. And so just to kind of go back to Rhonda and, excuse me, I forgot, Brett, to talk about a little bit about mindset. One of the things that I did on the first day is I showed this YouTube video called Never Give Up. And then, just kind of for fun, at the end of the class, we all said, never give up, and we love math. And then a couple of days afterwards, the new teacher took over. But it's kind of funny now. I'll be walking around the campus and I'll hear somebody say, "Never give up, Tricia." And if I walk into the classroom, the teacher will actually stop and the students will turn around and look at me and they'll go, "We love math, Tricia." And so it's just kind of a dumb little fun things that we do, but I think it does help change the mindset, and it's made the class kind of have a lighter feel to it and a lot of fun. Plus, because the students are seeing work that is relevant to their life and to the workplace, I think they're more engaged and they've been persisting better. And so usually if a course isn't going well, you know it by the second or third week, and we're entering the 5th week and still have the same students we had when we started. So far, so good. We're also, I wanted to mention somebody in the chat pod had talked about finding curriculum that was contextualized. And we had that same problem when we were trying to put this together in the consortium. And so we started trying to build curriculum, but then we found a book, it's McGraw-Hill, Workplace Skills, Applied Mathematics. And the thing I love about this book is it's all story problems, and it's all contextualized to the workplace. And so it's one of several books that she uses, but it's the one we use that has the word problems that are so important and that help students with reasoning through problems. So this class, I think, has been a huge benefit for our school in several ways. One is that we have a really good college tech program on our campus that has medical assisting, dental assisting, EMT, surge tech, and administrative assistant. And those, the CTEC program, you have to pass an entrance test to get into those programs. And the tests are the CASAS test. You have to score high enough on the CASAS test. And the math test they use is the 035M. And of course, you can't use the calculator on it. And as Rhonda's data kind of showed, it was surprising to me how many students fail that test. And so those students are referred over to my department, and we've been putting them into the workplace math class. Interestingly, too, we've had some students, so most of those CTEC programs started the very end of this month, and so we've retested some of the students and that we're wanting into the ones with the deadline for the end of this month, and they passed. But several of those students asked if they could continue staying in the math class, you know, as long as it continued on, and you know, as long as it wasn't in conflict with the new program they're starting. So also a good indication. This class helps prepare students for parts of the high school equivalency test. As you know, 55% of the test is algebra, but there are other parts that are not. And so in this work course outline, you see we do ratios and fractions and percentages and geometry applications. So they're getting the instruction they need for parts of the high school equivalency test, as well as it's helping them to be successful once they get into algebra. And then the other group that this benefits is a result of what I call the geometry fiasco. So our school district, a couple of years, not our school, but our school district, raised the graduation requirement to 200 for our school, and that included 30 credits of math. Now, most of the other adult schools in our area only require 20 credits of math. But we were okay with this because the intention was that we wanted students to leave with their high school diploma with a higher math level, and we were all for that at Mount Diablo Adult School. And so we immediately put into place a geometry class. Prior to that, the highest class we had was Algebra 1. And, oops, I'm just trying to watch my time here, was Algebra 1. And so it started the geometry class, and anybody that had already passed algebra went into this geometry class. And at the end, pretty much everybody failed. Why? Because they didn't have the algebra skills they needed to do the geometry. Maybe they had passed algebra, but maybe it was a long time ago. Maybe they don't remember it. Or even the basic skills, and definitely the math reasoning to get through the geometry class. So we had to take a step back, and interestingly enough, our school district has also found the same thing. While some students are able to accelerate ahead and take the higher level, there are students that just don't grasp it well enough to be able to do that. And so now they're instituting Algebra 1A, which is worth 10 credits, and Algebra 1B, which is 10 credits. So a student in our high schools can spend use 2 years going through Algebra B with really strong algebra skills. Uh-oh, having a little trouble. There we go. And then the last thing I just wanted to mention is we love our boot camps as well. We do have a Friday morning CTEC boot camp for the students who did not pass the CTEC entrance test but only missed it by a couple of points. So rather than making them take a whole class, we have a little boot camp. It's on Fridays from 9 to 12, and we use that in conjunction with Aztec. We use Aztec software, and we have them the pre-HSE module on that, and that's been pretty successful. And then in May, we have our boot camps for high school equivalency for those students that are still trying to pass that math test so that they can be in the graduation ceremony in June, because in our graduation, we have both high school equivalency and high school diploma. So that is what is happening at Mount Diablo Adult Education. Thank you.
Thanks very much, Tricia. And I know you have to zip off back to work, so thank you for being here. We're going to switch over now to Mala Allen from College of Marin, and she's going to tell us a little bit about their math pathways. So Mala.
Hello.
Hi, we can hear you.
Okay, thank you. Okay, so at College of Marin, one of the approaches that we are taking to help students achieve their goals of an associate or transfer degree or transfer degree to complete their bachelor's is to address the structural problem of having too many developmental courses in the sequence to getting to the college level courses. And you see on the flow chart, at the top of the flow chart, in order to get to the top, if you were placed in a pre-algebra, that's a lot of effort to get there, and because of low success rates and as well as attrition rate, is a problem that we needed to address. And so one of the things we decided to do was to pilot the Statway curriculum, and Statway is a curriculum that was developed by faculty working through the Carnegie Foundation for the Advancement of Teaching. It's a contextualized curriculum, and it includes community work within the classroom, so which is accomplished by creating group-oriented classrooms. The curriculum has prompts built into the notes for facilitating discussion among the class groups. So it is also contextualized to personal finance, healthcare, environmental technologies, information technology, and citizenship. We have completed our first cohort in spring with a great success rate. We had an 82% success rate for the entire cohort, which started in fall. So it's a two-sequence curriculum course. So if you look at the Statway 1 and Statway 2 on the left, those two courses together equate to the statistics course in the STEM pathway. The statistics is the same. They're both introductory college-level statistics courses, but one of the differences is that the Statway curriculum integrates the algebra into the course, the relevant algebra, so not necessarily everything. It leaves out everything it doesn't need, and so students are learning the math that they need when they need it as they're doing the statistics. Because of that, the other thing that's different between the two curriculum, the two approaches, is that Statway is developed for non-STEM majors. Non-STEM majors do not need everything that is in the intermediate algebra or elementary algebra as well. So we had such great success. We are actually starting our third cohort. We started this program last year in fall of 16. And because of our success, we were motivated to use the same approach with our pre-algebra course. And so what we start to do, in fact, this is the first semester we're doing that, piloting the it's called Quantway. It's also through Carnegie Foundation, and it's contextualized as well. We are piloting with 2 of our courses this fall with what's called Quantway curriculum for our pre-algebra course. So whether it's contextualized or whether it's the traditional non-contextualized curriculum for our pre-algebra, all of our Math 95s articulate to either the Statway sequence, or they're also satisfy the prerequisites for the elementary algebra, so they have a choice of which pathway they want to go through. And so at the bottom, and so that's at the bottom of the chart. One of the other things that we start talking about as well, because the pre-algebra requires a certain level of arithmetic skills, that we find still some students are not able to continue with the pre-algebra, and so our recent conversation is to develop a non-credit basic arithmetic course and using the contextualized approach as well. And we hope to have this ready by spring 18, or at least by summer or fall of next year. So just a little bit of a picture of what contextualized mean. Here is an example of a problem situation. We typically we always do, start with a problem situation that motivates the bringing in the math that you need to solve the problem. So in this particular case, the problem is not understanding what does a teaspoon mean when the doctor prescribes a teaspoon of acetaminophen, and when you get to the store, it's not in teaspoon form, it's in milliliters, and what do you do? So anyway, the problem motivates our actually working on our lessons on unit measures and unit conversions and so on. That's one example. Another example is using home improvement to motivate an introduction to lessons in calculations, measuring area, rates, and so on, and geometry. So, and these last 2, the first one. Hi?
You have a question about, hi, there's a question in the chat about what contextualized means. So are these examples of contextualized?
Yes, they are. So contextualized mean the traditional way of teaching the curriculum is pretty much you introduce, say for example, fractions, and then you add, subtract, multiply, divide fractions. It's very procedural, and most of it does not involve any kind of, when do I use this? So, which is a question we get a lot, is when am I ever going to use this math? And so in a contextualized curriculum, it's all about when you use the math. And so we bring in the math when you need to use it. And students see that this is part of, actually they do use a lot of this math every day. And it's interesting because sometimes in the class, a lot of time in class when we're using this curriculum, there's still a little bit of a disconnect from the students about they're not sure that they trust it very much, and so I just ask them to put away the problem for a minute. Let's just think about it. And then they see when they think through it, it's what they do a lot of times every day. When we're looking at percentages and calculating discounts and so. And so we're not looking at the piece of paper with that states the problem. I ask, well, what do you do? How do you calculate, figure out what's 25% off? And different students have different ways of doing that. But then they see it's actually what we are doing in class, and they're able to make that connection. and make sense of the math that they're doing.
Thank you. I think we have about one more minute.
Okay. And so for the next slide is an example for the StatWay, for the statistics course, where we're looking at nutrition facts labels from cereal. And the problem situation is trying to figure out how the consumer report what it uses to develop their rating. How do they do that? So we're actually discovering through looking at all the relationships between the sugar in the rating, the fiber in the rating, and so on. And students love this a lot. They get to do some sleuthing. So we've had a lot of success with this, and like 82%. And it also addresses the problem of the structural problem, because if we go back to our first slide, you see with the pre-algebra, elementary algebra, and intermediate algebra, again, because of the low success rates and the attrition rate, we lose a lot of students and not very many get to the college level. This way you go from the pre-algebra straight to the college level statistics course. And again, it's just for non-STEM majors.
Thank you so much. And thank you all of you, Rhonda Balmain, Brett Sanchez, Tricia Willett, and Mala Allen. Thank you for a large amount of information about math instruction, and thanks to all of you who attended today. When we close the meeting, an evaluation is going to pop up, and we really hope that you complete the evaluation to let us know if you got what you were expecting from this webinar or how you would like to see things improved, and also to give us any other ideas of other topics you would like to see have addressed in the AEBT webinar series. So thank you so much, and have a good rest of your day.